So when we look at electromagnetic radiation, we're talking about wavelengths and the size of waves. So let's understand waves a little bit better. All right, so here are some images of waves. If you look at this picture on the left, okay, it talks about amplitude. Amplitude is how high a wave is. The higher the amplitude, the brighter the light that comes out. The lower the amplitude, the dimmer the light. So if you look at the amplitude on those, you can see that the taller one is a little bit brighter pink and the shorter one is a little bit duller pink. Okay. When we talk about wavelength, okay, we're looking at the picture on the right side here. Wavelength is basically the distances per cycle. Okay, so we use this lambda symbol, looks like this, for wavelength. Okay, and again, larger wavelength means lower energy. Shorter wavelength means higher energy. Okay, and then we've got this other symbol, this nu, which means frequency, and that's how many cycles we go per second. So wavelength is the distance per a cycle, and frequency is the cycles per second. Right? Now, when we start talking about all of this stuff, we're going to start understanding that some things are going to behave like a wave, some things are going to behave like a particle, and some things are going to behave like a wave and a particle at the same time. So when we look at a wave, if I have a light wave that hits air, or it just travels through the air. If that light wave then hits water, it's refracted. So if you've ever seen light hitting like a glass of water or something, it bends the light at an angle. Okay, so we get this angle of refraction. Now, a particle has mass to it, which means it's affected by gravity. So if I take a pebble and I toss it through the air and it hits the water, instead of having a nice clear angle of refraction, because of gravity, it's going to curve. So if you notice here, we're curving. Okay, as we go down, instead of having a nice sharp angle like the wave did, because the wave doesn't have the mass to be affected by gravity. Now, if I have a wave that hits a slit, so here's my slit, okay, the wave's going to go through there, and then as it goes back through, it's going to start expanding back out again on the other side. But if I have particles, okay, any particles that hit the wall are just going to be stopped. Any particles that hit that slit are just going to keep going through that slit as though nothing was there. Okay? So it's important to understand this difference between waves and particles.